So today's video is going to concentrate on section 1.8. 1.8 is very similar to 1.7. We're still talking about the equations, we're still solving them, but this time we're going to be solving equations using multiplication and division. Last time we talked about solving equations with addition and subtraction. One of the other things we talked about last time were equations in general. What were equations? Equations are when you have two expressions and they're divided by an equal sign. So an expression on one side, an expression on the other side, and there's an equal sign in between. And since there's an equal sign, whatever's on either side has to be mathematically equivalent. For example, we have our 5 equals to 5. Now, if you remember from last time, I told you that you can do whatever you want to one side of the equation as long as you do the same thing to the other side. So here, I multiplied the left side by 2. I can do that. Why did I do that? Doesn't really matter. But I've unbalanced this equation. To rebalance it, I can multiply the other side by 2. Because now I have 10 equals to 10. And that's mathematically accurate. Let's look at something slightly different. Again, I have 5 equals to 5. My 5s look a bit sickly. That's okay. And let's say I divide the left side by 2. And I can do that. I can divide the left side by 2. Why? I don't know, but I can. But I have to keep the equation balanced. And to do that, I have to do this to the right side as well, which gives me 2.5 equals to 2.5. Different values, but they are equivalent. And that's the important part in equations. Also, last time I talked to you about inverse operations. Addition and subtraction canceled each other out. Addition and subtraction, if you added, let's say 2, and then subtracted 2, those two would cancel each other out. Well, multiplication and division also share this relationship. Multiplication undoes division, and vice versa. Division undoes multiplication. Let's take a look at that. Let's say I have 6 times 3. Pretty simple. That gives us an 18. And then let's say I take this 18 and I divide it by 3. The opposite of multiplying it by 3. And this gets me back to 6. Same thing if I start out, let's say, with 4, and I divide this 4, let's say, by, well, let's keep it simple, 2. I'm going to get 2. And then if I do the opposite of the dividing by 2, if I multiply by 2, I get back to 4. So as you can see, multiplication undoes division, division undoes multiplication. So let's keep that in mind and take a look at an example of an equation with a variable. Let's say we have this one. We have x times 3 equals to 6. Now, if you remember from last time, to solve an equation that contains a variable, we want to isolate the variable. We want to make sure that the variable is all alone on one side of the equation and there's nothing else with it on that same side. And we take a look at this particular equation with the variable, which is right here, x. And what's on the same side as the x? Times 3. So I want to get rid of this times 3. I want it to go away. What's the opposite of multiplication? Division. And what's the opposite of multiplying by 3? Well, it's dividing by 3. So I'm going to go ahead and divide this by 3. Now remember, whatever I do to one side, I have to do to the other side as well. So here we have 3 divided by 3, which is technically 1. And here I have 6 divided by 3, which is 2. Then I have x times 1 equals to 2. And we know when you multiply any number by 1, it's the property of multiplication by 1, it's the number itself. So we have x equals to just a 2. That wasn't so bad. Let's look at a different example. Let's look at, let's say let's go with m this time. M divided by 4 equals to 5. Just like before, this is an equation with a variable. And to solve an equation with a variable, I need to isolate the variable. I need to make sure it's all alone on one side of the equation. What's keeping me from doing that is this divided by 4. That's on that same side as m. I want to toss it away. I want to get rid of it. So what's the opposite? And I can do that by using an opposite operation. So what's the opposite of being divided by 4? It's to be multiplied by 4. So I'm going to go ahead and do that. I'm going to go ahead and multiply this side by 4. And whatever I do to one side of the equation, I have to do to the other side of the equation as well to keep them balanced. There we go. And once again, inverse operations cancel each other out, opposing operations, multiplication and division. So here we have m being divided by 4 and at the same time being multiplied by 4. They are opposites. So I'm going to go ahead and cancel them out. 4 divided by 4 is simply 1. So you get m divided by 1 equals to, and over here we have 5 times 4, which is 20. And we also know that dividing any number by 1 is that number itself. So m ends up being equal to 20. And here we have solved this equation as well, using inverse operations. This time the reverse of division was multiplication. In the previous problem, the reverse of multiplication was division. And as long as we remember that, and remember that whatever we do to one side, we do to the other side, we easily solved both of these equations with variables. So that's it for this video. In the next video that I make, we're going to be talking about section 1.9. And this is where you have problems that have both addition and subtraction, addition and multiplication, subtraction and division in one problem. So you have to apply both what we learned here as well as what we learned in the previous section at the very same time, but I'll keep that for the next video. So right now just keep this in mind, that whenever you have an equation with a variable and there's multiplication involved, you can use division, the opposite of multiplication, to solve this or to help you solve this, and vice versa. If you have an equation with a variable where there's division, you can use multiplication to help you undo that division and solve the equation. And once again, to solve an equation, you isolate the variable. You want to make the variable all alone on one side of that equation. So thank you very much for watching this video, and I will see you in class.